So should I refer to you as Daily? Or
Daily, yeah, that's
Daily
fine.
is enough?
Yeah, that's fine, I think, yeah. Yeah. I was going to ask. Do I have time to use the restroom?
I guess so, yes.
Yeah. I wonder whether...
It's
It might be in the corner.
it's way in the corner, yeah.
How many events do you have today?
Bloody 3 or something. Just Mr. Yes Man. Yeah. Do you mind if we just get going with the first speaker?
Not a problem.
Okay,
No problem. I'll be right back.
Okay, great.
Ronnie's not here.
I think we'll start. Daly needs to go to the bathroom. It's quite a journey.
Yeah, if you're a few minutes
I think we
delayed.
have to finish at 20 past, I think.
But the next session is ours too, so we have
Right,
15
I've got
minutes
a press conference in the locker room, so I might have to leave.
Yeah.
But I can always leave the discussion going.
Yeah, but
Yeah.
start when you think it's. But maybe wait 2 more minutes or so.
Yeah, I can.
How are you?
Pretty good.
Good. I'm Justin, by the way.
Yes. Hi.
Yeah.
Nice to meet you.
Good to see you.
I think we've
Still
got
waiting for the ambassador? No.
Yep. Okay, so I think we might get started. This next session concerns the risks to ecosystems and human systems from changes to ocean and cryosphere. And this is really a special event as part of the launch of SROCC, which is one of 3 special reports produced by the IPCC that's focused on oceans and the cryosphere. And I guess whether it is the reduction in water column mixing of the great ocean upwelling systems or rapidly intensifying underwater heat waves, we're seeing some really fundamental and devastating changes to the way the ocean and cryosphere operate. And so quite personally, I've been sort of quite shocked by the findings from SROCC. I wasn't involved myself, but it was shocking in terms of the escalating risks and the consequences of this for humans, which are sort of starting to be painted writ large. So this really then leads to the question, what do these rapid changes mean for ecosystems and people? And that will be the sort of major focus today. So we're going to hear from a number of experts, 3 in total, who contributed to the SROCC report on the subsequent risks to ecosystems and human systems. And in addition to these expert authors, we've got 2 external experts who will be taking us through some of the sort of updated risks associated with this issue. So in terms of the sort of logistics of this session, we're going to hear from the speakers for about 10 minutes each. We'll then turn over to the external experts for perhaps 5 minutes of commentary, and then we'll have the rest for discussion. So the first speaker is Javier Aristigu, who's from the University of Las Palmas de Gran Canaria, who will speak about the implications of climate change for the eastern boundary upwelling systems. Javier. This one's definitely working if you want to grab it. And I'll grab that one.
Okay.
Hold it close to you.
Yeah, okay.
Okay, good morning or good afternoon now. Thank you very much for the invitation being here. Okay, I'm going to talk about eastern boundary upwelling systems, which are called EBUS, and particularly about these coupled human natural systems. So this is part of the SROCC report, chapter 5, and it's a special box there, so you can get more information if you go to the report and you find it there. What's an EBUS? An EBUS is a coastal ecosystem when there is upwelling of water due to the displacement of surface water offshore due to the combination of the trade winds and the rotation, which produce this displacement and then is replaced by deep water coming up with, which is cool and is nutrient rich, and hence it produces an increase in productivity. These are located in 4 eastern boundary currents, which you have here in the map. One is the California current, the Humboldt current extending from Chile up to north to Peru, the Bengala current here, which also extends from South Africa to Namibia, and the Canary current, which in fact extends to the northern Iberian, and most of it corresponds to the Northwest African coast, but also to the Canary Islands, which are in the transition zone of this eastern boundary current. So why EBUS are important? First of all, they are among the most productive ocean ecosystem. They contribute roughly about 17% of global catch. These of the catches may be consumed locally, but others may be processed and exported as seafood, fish meals, and oil to support aquaculture and livestock production. They also support lucrative ecotourism, such as whale watching, because they are highly productive ecosystems. On the other hand, the condensation of humid air in coastal areas benefits coastal vegetation and agriculture and may suppress forest fires. But what is really important in these terms related with climate change is that some of these EBUs, particularly the Pacific ones, are close to important thresholds in terms of oxygen loss and ocean acidification. So what are the observed changes? In terms of wind and upwelling intensification, the studies from the past 60 years have shown that all these regions except the Canary current, they have intensified in terms of wind and upwelling. And this is due mostly to the increasing gradient in the atmospheric pressure between the high and the low on the continents, which has increased this difference due to global warming. But there are other impacts to these ecosystems. In this plot here, where you are having here is in this part of the panel, you have the physical changes in the ecosystems and the impacts on the ecosystems and the human systems also. So the line here at the right, you have physical changes. You have the increase in yellow, decrease in green, and when you have either increase or decrease, you have green and yellow. And these are in the systems. They are blue and red, so red are negative. And then you have the attribution confidence here with this dot. So 1 dot is low confidence, high dot is 3 dots are high confidence. So you look at this, basically in the EBUS, in the physical changes, there is only one parameter here, which is ocean pH, which has a high confidence. So it's decreasing, and particularly, I say it again, is in this Pacific EBUS, where they are really decreasing pH and going to very saturating states of the calcium carbonate. Some of the EBUS are rising temperature, others are decreasing. So for instance, the California current is decreasing the temperature. The Canary current is the opposite, it's increasing temperatures. You go down here, you see that there is very low confidence in many of these risks or these impacts, and the reason is because the natural variability in eastern boundary regions is very high, and it's quite difficult to discern the natural variability from the emergence of these climatic variables. So projections tell us that it will be in the second half of the year when it will be a time of emergence of many of these variables here. But if you look anyway, you can see that many of these ecosystem impacts all of them are negative. So they are affecting negative fishery, terrains, and habitat services, as well as, for instance, some coastal ecosystem like kelp forest there. So what projections tell us? Well, future projections, for instance, using these Earth system models, tell us that there will be reduction of wind and upwelling intensity in EBUS at low latitudes and increase in high latitudes. But this decrease in low latitudes could be in the intensity, but could be also in the extension. And there, if you look at this figure from Ryanovsky here, it's a very nice figure. You can compare the 4 eastern boundary regions, and you can see that there are regional difference, not only between the EBUS, but also along the same EBUS. So you may see a strong decreasing here into the north of the Canary current system and a strong increasing in the lower part and central lower part of the California current. So there is a large variability. There are other projections dealing with biochemical proxies here. For instance, model projections for 2100 suggest that there are strong effects of deoxygenation and reduced pH in the Pacific EBUS, particularly in the Humboldt current. You may see here in this panel that mostly at the end of the century, the 2 different states of the calcium carbonate, the calcite, particularly aragonite, but also calcite, may drop below the saturated state. So this means that it's going to be corrosive. It's going to be a dissolution of shells here. And this is really worrying because this is almost even applying the low emission scenario, which are RCP 2.6. And what about prior production? Well, prior production is, we really have very little information about prior production. Earth system models, they don't reproduce really well the coastal ecosystem in terms of high resolution coastal ecosystem. So this is one of the main, I think, the main conclusions of this panel here is that local winds and these mesoscale oceanographic features, but also local warming, may have more importance than large-scale winds in the productivity of these coastal regions. And we have to go to high-resolution models like Round's models to look at these features, because there is a decoupling many times between large-scale winds and productivity in these regions. But at the end, what we see here, either by RCP 2.6 or 8.5, is that there is in subtropical and tropical waters, there is a decrease in prior production at the end of the century. And this translates pretty well when we look at how this translates to the upper trophic levels, for instance, on the fish biomass, but also on the maximum fisheries catch potential. You may see here in the panels that there is a coherence, a very, is not pointing? Okay, sorry. In that way, there is a very good coherence in prior production, fish biomass, and catch potential. But one important thing is that there is an amplification of these signals. So if prior production is reduced by, let's say, 5%, fish biomass will be reduced by a higher number in that. So this is quite important. Fisheries, of course, or catch potential depends also on fishing effects on the exploited populations. So if you look there in that panel here, you will see that, for instance, South America in the Humboldt current, you will see that south of South America there is like increasing productivity, and north of in the Peru area there is a clear decrease in productivity. So there are regional difference, clear regional difference that we have to address. Sorry, I'm just finishing. And this have implication particularly for vulnerable population, human population that depends on these local fisheries in terms of having their own micronutrients for their survival. And this is quite important in terms of adaptation. So we have to think on how we manage all these fisheries because they are so important for these communities living in the coast, particularly in the Canary Current region. Many West African countries depends on them. So just ocean risk reduction, ocean-based responses, there are a number of them, and many of them may have a lot of benefits, like they are mostly nature-based solutions, like conserving and restoring coastal vegetation, marine protected areas, reducing pollution, or eliminating over-exploitation. And this has a lot moderate to high benefits to local climate risk reduction, but also they have very high co-benefits and low trade-offs. So just summarizing here, we say that given the high sensitivity of this couple, human natural EBUS to oceanographic change, the future sustainable delivery of these key ecosystem services, particularly fisheries and aquaculture, is a risk under climate change. This is more a risk for vulnerable human communities with very low adaptive capacity. These have very high risk of altering their development pathways. So EBUS are sentinels of climate change. They sustain us. They are under pressure. Their changes affect all of our lives, but particularly of the less developed countries. So it's time for action now. Thank you very much.
We'll leave the questions until the discussion, if that's all right. The next speaker is Elvira Polochanska, who is a leading authority on biodiversity and climate change. And she's going to talk about the impact and risks for global marine biodiversity and fisheries. Elvira.
Thank you. Just wait for my slides. Thank you. So I'm with the Technical Support Unit of Working Group 2. I'm the Science Advisor to the co-chairs and the TSU. And I'm going to unpack SROCC from the perspective of impacts and risks for global marine biodiversity and fisheries. So just to start, oops. This is down there, right. I'm pointing at the wrong thing. Okay, so just to give you some background, so anthropogenic greenhouse gas emissions are leading to ocean warming, ocean acidification, and oxygen loss. So the warming trend that was documented in the 5th assessment report is continuing, and the rate of warming is increasing. We're also seeing increases in the frequency of marine heat waves. These are periods of increased thermal stress in the ocean. And they're becoming longer, more intense, and more extensive. The ocean's also acidifying and is losing oxygen in the upper layers. And in the future, the ocean's projected to transition to unprecedented conditions. So ocean warming is going to continue. So on the left-hand side here, the graph in the middle shows you the projections for global mean surface temperature. The orange line at the top is under RCP 8.5. This is the high greenhouse gas emission scenario. And then the blue line at the bottom is under RCP 2.6, where we have a 2 in 3, where the models project a 2 in 3 chance of staying below 2 degrees C. So SROCC confirms the conclusions from the AR5 from the 5th assessment report of Working Group 2. So this is from the Working Group 2 5th assessment report, and it shows that responses of species and ecosystems to climate change have been observed from every ocean region. And SROCC confirms this and provides further evidence that more evidence of these changes and that these changes are continuing. This is from Chapter 5 in SROCC and shows that marine species across various groups have undergone shifts in their geographical ranges. So we're seeing biodiversity starting to redistribute in response to warming. Here we're looking at three taxonomic groupings, so zooplankton at the top, and don't forget that zooplankton include larvae from fishes, including commercial fishes, larvae from crustaceans, as well as zooplankton that stay their entire lives floating in the upper ocean water. The lower panel is for fishes, and then over on the side we look at marine mammals, seabirds and turtles. So you can see that there are differing responses in terms of range shifts. This is over 50 years, from the 1950s up to about 2012, I think it is, and shows and documents the degree of the range shifts. So basically we're seeing shifts up to 700 kilometers per decade for zooplankton and for fish communities. We're also seeing some species that are going opposite to expectations from warming, but actually overwhelmingly the response has been consistent with what we would expect to see from our knowledge, from multiple lines of evidence in response to temperature. So the average shift rate in the ocean, in the upper ocean for the pelagic species is 52 kilometers per decade at present. And why are we seeing these shifts? Why do we expect to see biodiversity redistributing? Well, life is specialized on limited temperature regions, and this is particularly true in the ocean, where the scientific evidence has shown that marine species tend to fill their thermal niches, so they live within the boundaries that they're physiologically able to, and they're responsive to temperature. In fact, temperature is one of the major drivers of biodiversity patterns in the ocean. In some marine species, but temperature is not the only variable that's changing. Other human activities, such as fishing, are also influencing species distributions. And what SROCC shows is that altered interactions between species have cascading impacts on ecosystem structure and functioning. So we're already seeing evidence of these for ecosystems around the world. And drawing on Javier's report, also what we're seeing is that global warming and biogeochemical changes have really contributed to reduced fisheries catches in many regions. So Javier gave a very nice introduction to my talk. He took you through from the primary production to the changes in fisheries catches. And this is the graph from Chapter 5 again that shows changes in marine biomass in the oceans, again under the two RCPs, under 2.6 and 8.5. Oops. And you can see that under the high greenhouse gas emissions scenario, on average, across the global ocean, there'll be a decline in biomass of around 15%. So to look at the regional changes, that was the global picture. Now we'll look at the regional picture. And that you can see under both RCP 2.6 and 8.5, there are regions of the ocean where these decreases, these are the areas in orange, are projected by the end of the century. This is particularly around the tropical regions. So you can see the very large decreases up to 50% in equatorial seas. And this has implications for fisheries catch potential. So as we heard from the previous speaker, that as biodiversity changes, so will the fisheries catch potential. So this is the amount of biomass available to fisheries changes. And again, you can see that in these tropical oceans, again, is the places where we see the large decrease. So globally, we expect we're projecting again to the end of the century, global, and this is under RCP 8.5, global decreases of around 20 to 24%. And in tropical waters, however, this may be up to 50% of maximum fisheries catch potential. So SROCC highlights that the biomass of fish and catch potential on average will decline towards the end of the century, but with regional increases. There are some areas of the ocean where increases will happen. And this has positive and negative impacts on catches, on economics for livelihoods, and also for local culture. And there are many communities that are highly dependent on seafood, and they will face risks to food security, and they will also face risks to nutritional security. And changing redistribution of marine biodiversity also brings challenges to fisheries governance. And there's an expectation highlighted in SROCC that these challenges will become more widespread in the future, particularly under the higher emissions scenario, as marine biodiversity redistributes. So this is a summary slide from the FAQ in Chapter 5 of SROCC. And even though I've been speaking mainly about focusing on temperature and the redistribution of biodiversity, temperature is not the only variable, not the only impact that's going to affect biodiversity. At the same time, as I showed you in the very first slide, we've got ocean acidification, we've got loss of oxygen, we've got marine heat waves. However, changes in the ocean and cryosphere will bring range changes in species, so we will see local species migrations and local species extinctions. There are many other impacts in the oceans that will compound and in some cases exacerbate the impacts of climate change. And they include, for example, overfishing, they include pollution. And there are consequences for our marine biodiversity. So with the redistribution of global biodiversity and with the compounding impacts of climate change and other anthropogenic stresses, we expect to see loss of charismatic megaspecies. We will see disruption to ecosystems and loss of biodiversity and habitat. However, these other human impacts may also be places where some of our solutions may lie. So these are where we might look for some of our responses. So SROCC also highlighted how to strengthen response options to the changes in to the impacts brought about by changes in the oceans and cryosphere. So reducing other pressures such as pollution and habitat modification allows species and humans to adjust to changes in their environment. Policy frameworks for fisheries management and networks of protected areas, so anticipating where biodiversity may redistribute, will allow conservation planning and spatial planning to incorporate this information for networks, maybe corridors of marine protected areas where species can find refuge as they're moving. Strengthening precautionary approaches such as rebuilding overexploited and depleted fisheries and responsiveness of existing fisheries management. Nature-based solutions such as ecosystem restoration and connections with local and indigenous knowledge. And all of these will bring multiple benefits to biodiversity, to the humans that depend on marine life, and in some circumstances for climate mitigation. So, for example, restoring coastal wetlands brings benefits for carbon sequestration and ultimately climate mitigation. Connections with local and indigenous knowledge. So some of these efforts are going to be most effective locally when they connect with local communities and when they, including local indigenous communities. However, there will be limits to this. So some ecosystems, for example, coral reefs, are already at high risk from climate change, and increasing warming, increasing climate change, increasing warming will reach limits where response options will no longer be effective. So the ultimate message from SROCC is that the more decisively and earlier we act, the more able we'll be able to address unavoidable changes, manage risks, improve lives and achieve sustainability for ecosystems and for people around the world, both today and in the future. Thank you.
Thank you very much. The next speaker is D.T. Mukherjee from the International Water Management Institute. Sorry. The next speaker is D.T. Mukherjee from the International Water Management Institute, who's going to talk about water systems and security.
Thank you. Which one? Which?
It's arrow
This
forward
one.
and arrow back, yeah?
Yeah. Good afternoon, everyone. I'm going to talk about the mountain chapter in which I was involved as a review editor. So I was not one of the writers, but review editors, I mean, if you know how the IPCC system works. Chapter 2 was around high mountains, and in this I'm going to focus on the impacts of changes in the high mountain region, specifically in the cryosphere, on water resources. So the overall conclusion from the chapter was that smaller glaciers, for example in Europe, Eastern Africa, but also glaciers elsewhere such as in the Hindu Kush Himalayas, are projected to lose more than 80% of their current ice by 2100 if current levels of emission continues. And these would entail a number of hazards for people such as landslides, snow avalanches, etc., as well as floods. Another high-level conclusion was that changes in water availability would lead both water quantity as well as quality would affect household use, agricultural use, as well as uses in hydropower sector, and also will affect recreational and as well as other cultural assets. In many of these countries, glaciers and ice and snow also have a very high aesthetic as well as religious values. Coming to the water in particular, as all of us know that mountains are really the water towers of the world, and that's where majority of our rivers originate. So if you take the example, and I come from the Hindu Kush Himalayan regions, I'm from India, and 10 major rivers of Asia, for instance, originate from the Hindu Kush Himalayan mountains. That's true for practically all the other mountain ranges. Those are the places where rivers originate from. So one of the conclusions, high-level conclusion of the chapter is also that there is a very high confidence that there are already changes in seasonality of water flow in both runoff in snow and glacier-dominated rivers across the basin, and hence severe impact on water quantity. Just to, and this has led in some river basins, for instance, those dependent on glaciers, such as in tropical Andes or in Swiss Alps or in Western Canada, the peak water flow has already come and gone. So basically, peak water flow is when the glaciers melt and the water runoff is at the highest, and then it kind of goes down because there's no longer glaciers. So that has already happened in these places, and peak water level will pass by the middle of century in high mountain Asia. So these were some of the graphs that the chapter has. This is graphs from chapter 2. Around two scenarios, RCP 2.6 and 8.5, where you can see that those peaks are, in low latitude glaciers and river systems. You already had the peak water, the peak discharge was right now. While in some places like high mountain Asia, the peak discharge is going to be around mid-2050, and after that the runoff is going to decline further. So these were some of the numbers. Then there was a FAQ figure in the chapter that kind of talks about in pretty simple terms of what this changes in what happens before peak water, at peak water, and after the glacier has melted away. So this kind of, gives a pictorial, a simple pictorial diagram of what will happen to river runoff and river flows after glaciers have melted due to increased temperature. Then the chapter also talks about evidence that there has been changes in water quality. For instance, there has been significant shifts in downstream nutrients and water quality and influence on water quality through increases in heavy metals. So both quality and quantity changes due to melting snow, ice and glacier are documented in the chapter. Then another section of the paper of the chapter talks about the increased societal impacts because of these melting glaciers. For instance, there is robust evidence about impacts of changing river regimes on hydropower, and those are from all over the globe. Almost all hydropower, there's a lot of evidence about how the operation of hydropower is going to change because of changing water regimes. Then there is also a lot of evidence around, medium level of evidence around impacts of these changes in stream flow in agriculture and in irrigation. The point to note is that not many of these rivers actually, not many of these glacial-fed rivers, not many glaciers actually support irrigation because they are often at a very high altitude. And therefore, I would think that the evidence is on the medium level. And then there is a lot of evidence around glacier-related floods and GLOFs, etc. I'll just skip that for the time being. So, yeah, this was some of the figures. So, okay. So the major conclusion of the chapter was around that glacier melt is something that you can very directly relate to temperature increases. And I mean, this is one of those really clear climate signals. And here limiting to 1.5 degrees seems to be the only thing that would, help people adjust to changes in water supplies, etc. Then there was also discussions around integrated water management and transboundary cooperation. I'm happy to discuss them if needed. Then what I also wanted to do was to, so that was basically the SROCC chapter on mountains. And I also wanted to take a few minutes to talk about the Hindu Kush Himalayan glaciers. And this is based on another assessment called the HIMAP assessment, which was done in the region of the Hindu Kush Himalayas by the 8 governments in the region. So this is the Hindu Kush Himalayas all the way from Myanmar to Afghanistan. And here the projections, and these numbers have been also quoted in the SROCC mountain chapter, and it shows that in a 1.5 degree world, glaciers in the HKH will, almost 1/3 glacial loss would happen in the HKH, and that's in a 1.5 degree world. And at 2 degree global warming, there would be almost 49% loss of ice volume. So those are quite big conclusions. Well, this is, if you keep your eyes fixed in one position, this is the northern face of Mount Everest, I believe. And if you keep your eyes focused on one point, this is actually fascinating. This kind of shows the changes of what happened in Mount Everest. I can do that again, actually. It's, yeah, keep your eyes focused on one place and then, yeah. So these kind of visible changes are very, very clear. What do these mean for the region's water resources? So these are some of the communities that I have worked with, my colleagues in my organization, my previous organization, we used to work with high mountain communities. And you see those glaciers up there, and then these are only the fields, the green fields. So these were the only sources of water for them. And these communities would often ask us, what can we do, how can we adapt? And the answer is really they can do very little to adapt, because there's very little that they have contributed to those glaciers melting up there. So this is one of those places where I think, again, the loss and damage is also pretty clear, that most of it is happening because of glacier melting, and glaciers are melting because of global temperature rise. So in this region of the Hindu Kush Himalayas, which has the 3 bigger river basins of the Indus, Ganges and the Brahmaputra, here the main conclusion was that we are not running out of water. The greatest impact would be for those communities, high mountain communities who live near those glaciers, and those are anyway very vulnerable communities. They tend to be ethnic minorities. They tend to be more poor than the rest of the mainstream population. So there is already a high level of vulnerability among those population. And also climate change in these three basins is expected to drive consistent increase in total runoff. In the Indus, and Indus basin that's shared by Pakistan and India is the one that's most vulnerable, followed by Ganges and Brahmaputra. And Ganges and Brahmaputra are a little less dependent on glacier and are more dependent on rainfall. So the impact on them is likely to be a little less. Then we also did similar work around flood magnitude, and the conclusion was pretty clear that flood magnitudes would increase. And intensities of once in 50-year floods would increase by 40 to 110% in upstream areas, that is nearer the glaciers, and yeah. So I think that is all that I had to say. Yeah, it wouldn't move anymore. Yeah, okay. Yeah, okay. This was something that was already in the slide. Thank you.
Thank you very much, Aditi. We now have comments from two external experts, and so the first is Ambassador Ronnie Jumao, who has agreed to make some contributions. So, Ronnie, would you like to take the podium? That'd be good.
Thank you very much. As the moderator said, I'm Ronnie Jumao. I'm Seychelles' ambassador to the UN and a lot of other hats I wear. When I mention Seychelles, you think of beautiful islands in the middle of the Indian Ocean. On a map, those islands feature as pinpricks, and on some maps, we don't feature at all. However, and we always say, as you know, our story under the Alliance of Small Island States, we contribute the least to climate change, but we suffer the most. But it does not mean that we cannot be amongst the biggest contributors to the fight against climate change if we change the way we look at ourselves. If we flip from small island developing states to large ocean states, or as I prefer, big ocean states, because that means we're bosses, the story changes dramatically. Let me give you a background before I tell you what we'll be doing. Seychelles is made up of 115 islands, totaling 455 square kilometers. Our EEZ is 1.4 million square kilometers. Our EEZ is 3,000 times bigger than all our islands put together. Meaning our total size with our EEZ, we are more than 99% water. As I say, we're a liquid nation. So one of the things many islands do as thinking as islands and the land territories we come from is that how much can we contribute to the fight against climate change? If you think as a large ocean state, the natural assets that we can bring to bear in the global fight against climate change increase 1,000 or several thousand-fold, as I showed you. And that is obviously nature-based solutions, ecosystem-based adaptation. And why I'm talking about this here in this pavilion, where the IPCC also is, for a country to claim a nature-based solution as a mitigation component of its NDC, it needs to be able to measure how this is reducing emissions and how it can manage this function effectively. Now, the IPCC currently recognizes only 3 coastal ecosystems: mangroves, seagrass beds, and salt marsh, for their quantifiable mitigation value. Seychelles has always wanted to champion oceans in general, blue carbon in its NDC. I think that's the biggest contribution islands can make. Because, for example, a lot of us have plans to go to 100% renewable energy. Look at these islands. Even if we all reach 100% renewable energy, in the grand scheme of things, it's nothing. So Seychelles, what we did is we've been talking to potential partners for 1 or 2 years now, saying, look, one of the things we're doing in Seychelles is by the first quarter of 2020, we will protect 30% of our territory. That is the size bigger than Germany. Imagine Germany with only 95,000 people. Imagine Germany underwater with just 95,000 people. You can't conceive it. But we've always said, okay, we're protecting 30% of our territory, nearly a third. Obviously, biodiversity reasons. Some of it has got to do with fish stocks and thus livelihoods. There are various reasons we're doing it. So we say, by next year, we'll give you the GPS coordinates. This is where the water the ocean is protected. Then what? Okay, we're strengthening the resilience of those areas to act as a carbon sink. So, this is what we talk to our partners. We want something scientific. We want to be able to go to the Paris Agreement and to the global stocktake and in 2020 to say, when we protect 30%, this is what we mean in emissions. This is, and it strengthens our argument to say we are actually absorbing, storing emissions of other people, because no one is going to convince me that 400,000 square kilometers worth of emission station is being emitted by the 95,000 people of Seychelles. It gives us a stronger scientific strength. So Seychelles, of the three, I said seagrass, mangroves, and salt marsh, we definitely have a lot of seagrass and mangroves. Our mangrove systems are more or less well mapped. And with the support of a World Bank-funded project, we will draw up a coherent baseline habitat map. But it is with seagrass that we'll take our next pioneering ocean action. Why do I say pioneering? Apart from protecting 30% of our ocean territory, Seychelles has been a pioneer in innovative financing to address both the Paris Agreement and the Sustainable Development Goals. We did a first-of-its-kind debt swap with the Paris Club, to a $22 million debt swap to raise financing for communities on the ground to be able to contribute both at the same time ocean climate action and also address sustainable development goals. And we launched the fund, the trust, the Seychelles Conservation and Climate Adaptation Trust in 2017. Through the debt swap, we then funded 6 projects worth $250,000. Even then, with a population of 95,000 people, and 21% of whom are guest workers, foreigners, it's a lot of money for a small country like us per capita. In 2018, we funded, I think, between 7 and 9 projects worth $500,000, just under $500,000. 3 years after we launched the fund, this year, we have funded, all with grants, 21 projects worth $890,000 out of the debt swap. No other country in the world that we know is doing this, and they're all for sustainable marine activities. Last year, we launched the world's first sovereign blue bonds for sustainable fisheries and marine activities, guaranteed by the World Bank, partly funded by our contribution from our money from the GEF. And that is money guaranteed by the government to be lent to the private sector, private marine sector, to take on sustainable activities. So we're always being asked, Seychelles, what's new? What's the new thing? So the next new thing, I come back to this, is what we're going to do about putting seagrass and mangroves in our NDC. But compared to salt marsh and mangroves, seagrass is difficult to map, obviously, because it's underwater. And there are currently no global estimates of seagrass habitats around the world. Best practices for remote sensing and validation are advancing, but relatively few pilots exist. So what we are doing is we are working with Pewtrust. They are the people who responded to this call to us that we wanted a scientific approach to not just protect, is what do we do with the protected areas. So we're working with Pewtrust, Oxford University, the University of Seychelles and other local stakeholders, and with the support of the Nature Conservancy, who are part of the debt swap, which allowed the protection of the areas that we're going to cover. We intend to commit in our next NDC to fully map our seagrass ecosystems and use, and this is why I'm speaking here, the appropriate IPCC guidelines and methodologies to assess their carbon value. So we're crossing over from planning to actually establishing just the protected areas to now going to a more scientific approach that we hope will be a model for other large ocean states where if all the states step forward, we like leading by example, we like shaming people by example, by being very ambitious, very proactive in the things we do. And this way, we will also be an example to even other large ocean states, which are not necessarily small island countries. So I hope this work will provide further justification to protect these ecosystems in Seychelles. Not that we really need them with the local populace. Like everywhere, you still have some problems with the fisher folk because they get affected, and it's an ongoing conversation. And one last thing I'd like to say is, in the last round, or really the first round of NDCs, many countries acknowledge the broad-scale potential of coastal wetlands and blue carbon ecosystems, and various countries did include the ocean in one way or the other in the NDCs. Not enough. Ours is certainly inadequate. But very few, if any, provided specific assessments of the carbon value and subsequent targets for their protection. One of the things I say when I talk about the innovative things we're doing around the world to encourage fellow large ocean and also coastal states to take the large ocean, small islands to take the large ocean approach, is I started out by saying when we were planning our debt swap and the blue bond, I said it can be done. Now we say it is being done. We are delivering with a partnership of different partners, of governments, of the World Bank, the Global Environment Facility, Pew Trust, TNC, Wade Foundation, Oceans 5. The list goes on. The blue loans, for example, the blue bond, part of it's $15 million in blue bonds that we launched last year, 13 million in their blue loans. The blue loans are being managed by the Development Bank of Seychelles, which itself is a PPP between the government of Seychelles, the French Development Agencies, the multilateral arm of the French government, and Standard & Chartered Bank, a private bank in the UK. We are reaching across every type of partner you can find so that, as we said, when we graduated to high-income status, as my president said at the G7, Seychelles did not complain about losing access to grants and concessional funding. We embraced it because it was an indication of our success. Now what we're trying to find, because many poor countries and middle-income countries, they don't want to graduate because they know what they're going to lose. We're trying to show them, when they graduate, what they are going to gain, this brave new world that's out there. Then the people are saying the money is not reaching us. What we're doing is we're not asking for the money to come to us. We're going after it. That's what an ocean does. It flows and fits in and finds the least line of resistance. This is what water does as a true ocean nation. So I'm hoping that what we are doing in Seychelles will inspire small island states to come forward as large ocean states, as bosses, and increase our contribution to the fight against the help solve a problem that we didn't create. Thank you.
Thank you very much, Ambassador. The next and final contribution comes from Dali Sambo Dora, who's the chair of the Inuit Circumpolar Council. Dali?
Qiyanak, thank you very much. First of all, as I said yesterday when the special report was delivered, that we Inuit greatly appreciate the fact that the special report did include people and put a human face to the issues concerning oceans and the cryosphere. My position, my title is the International Chair of the Inuit Circumpolar Council. We represent the Inuit throughout the Arctic region of the Russian Far East, or Chukotka, throughout Alaska, Canada, and Greenland. I've been harassing my colleagues at Dalhousie University in the geography department to give me the exact percentage of the Arctic that we occupy. They haven't given me an answer yet, but I know that it's certainly well over, or just over 40% of the Arctic region. So as you might imagine, this particular report is of great significance for Inuit throughout all of Inuit Nunat. I want to read a quote because the theme of this gathering is ecosystems and human systems. In 1977, in response to the international community's proposed ban on Aboriginal subsistence whaling, one of our leaders stated, "The people who call themselves conservationists have chosen not to conserve the Inuit. We are further compelled to tell the world who we are, the total depth of our environment, and our association with the whale is dependent upon the survival of both communities, the whale as a species and the Inuit as a species." Pretty clear linkage between ecosystems and human systems. And I think it's important to underscore that this message and this perspective of a holistic view of the world and being a part of the ecosystem, and the whale being a part of our lives and spirituality, even the complex and sophisticated protocols as to how a whale is taken and what's to follow when a whale is landed. The sharing of the food in the community, the division of tasks between women and men. Everything is interrelated, interconnected, and indivisible. If you change one element, it affects the whole. So the special report is significant in terms of the items that were identified in terms of human systems and inhabitants of the Arctic region. I want to share another quote, which is important to this report, and it was made by the late Eben Hobson, who's recognized as the founder of our organization. In 1977, he had the foresight to bring our people together, despite the fact that we were in the midst of the Cold War, and then Soviet Union didn't want our relations. Not very far away from us in Alaska, directly across the Bering Straits, and those who study oceans know that the Bering Strait is a choke point between the North Pacific and the Arctic Ocean. So we see a lot of activity in this area. But Eben Hobson had the foresight to bring our people together to unite us in order to ensure that we have a voice at the international level. I'm sure he did not realize that we would be in the midst of a COP25 at the UNFCCC when he uttered these words, but he had incredible foresight. Our language contains the memory of 4,000 years of human survival through the conservation and good management of our Arctic wealth. Our language contains the intricate knowledge of the ice that we have seen no others demonstrate. So here and now, I think one of the critical things, and it was identified in this particular special report, is that we have something to offer to the world community as far as adaptation and mitigation. Clearly, we're pretty good at adaptation. We've managed to survive and sustain ourselves within a very harsh environment. I kind of chafe at the use of the term resilience, but we've been able to adapt. And we're now finding ourselves adapting to the changing Arctic that's been identified through this report and certainly by the presentations that have been made before mine. One of the clear impacts is food security and the fact that we rely upon the marine environment. We rely upon all of the marine mammals, and the whale is just one of them. In the Bering Straits on St. Lawrence Island, the walrus is the keystone species there. Our communities in Savunga and Gamble have relied upon the walrus. Our active hunters and harvesters are observing through community-based monitoring and all kinds of other activities exactly what is happening in terms of the ecosystem and their place within the ecosystem. And so they have highly sophisticated knowledge about the behavior of walrus. So it's not just a spiritual relationship and food that you put on the table, but an understanding of what that particular marine mammal does within the environment, the changes that they are seeing, how they're calving, how they're birthing, normally birthing and calving on sea ice, but because there is no longer sea ice, doing so in the water. This is an adaptation that has been witnessed by our people. So the impacts that were identified in the special report are, I guess I'm just here to say, yes, it's true. All of these findings, which are alarming and should cause alarm, are in fact true. And we can, through indigenous knowledge, complement Western science and the information and the data that is being collected. In that regard, I think it's important for me to say that, and I heard it yesterday during the delivery of the report, there was a consistent reference to stakeholders. And I want to underscore that Inuit are rights holders. We as indigenous peoples, as distinct indigenous peoples within this region, have rights, and we have rights to our lands, territories, and resources, but we also have the right to participate in matters that directly affect us. And so I guess what I'm suggesting is that in terms of the knowledge and what we have to offer, I want to really highlight indigenous knowledge, the value of indigenous knowledge, the legitimacy of indigenous knowledge, and for us to dialogue about how we move forward in an ethical fashion to bring indigenous knowledge together with Western science. And our organization has developed a definition for the term indigenous knowledge, and we've done this on the basis of what active hunters and harvesters, fishers, and people that are out there and on the land, out on the coastal seas that we depend upon. So it sounds, in English, it sounds very technical, but it really was born out of the views and the observations of the people out there and in our communities. So the following is the definition that we have adopted of indigenous knowledge. Indigenous knowledge is a systematic way of thinking applied to phenomena across biological, physical, cultural, and spiritual systems. It includes insights based on evidence acquired through direct and long-term experiences and extensive and multi-generational observations, lessons, and skills. It has developed over millennia and is still developing in a living process, including knowledge acquired today, and in the future, and it is passed on from generation to generation. So you can imagine how even in this context, the adaptation is beginning to impact the language. And we've heard from other indigenous peoples that are very passionate about simply the matter of language, but we're beginning to see people struggle with changing terms because the ice conditions have changed, the snow conditions have changed, and so forth. So I just want to conclude that in terms of how the IPCC goes forward in really delving deeper into ecosystems and human systems, to recognize and respect and outreach to organizations like ours who are prepared to help contribute to the co-production of knowledge, and also ensure that we have the intellectual and policy space to begin defining exactly how co-production of knowledge develops in this context. And I think it's not only useful here within the UNFCCC, but it's also useful in many, many other fora. The final point on co-production of knowledge is pretty straightforward. It's pretty common sense that you engage indigenous peoples from the beginning to the end, and at every stage, procedurally and substantively, to recognize not only our rights to directly participate in matters that affect us, but also just in the common sense way as to how you co-produce knowledge. I have all kinds of anecdotes about a marriage and the idea of co-production, right? You know, we all, those of us in these kind of partnerships, we know what co-producing knowledge is, or co-producing a budget for the family, or, you know, whatever it happens to be. So it's pretty straightforward and it's pretty common sense, but I appreciate the opportunity and I appreciate being invited to share these few remarks. So,
If you'd like to stay there, we'll get the other speakers up onto the stage. So you're not out of the jail yet. We've got now about 15 minutes to have a discussion. So if I could ask the other speakers to join Daly on the stage. It's one for you. Great. Well, first, I think we need to thank the people up here on the stage for a really fascinating set of perspectives. I don't think it could have been any better. It was fantastic. So let's thank the speakers and experts. Now for some questions. Okay. If you could state your name and where you come from.
Okay, can you hear me? Evgeny Aksenov, National Oceanography Center, United Kingdom. I just got a question about the Earth system modeling. I think you probably mentioned some deficiencies in the simulating shell of ecosystems and biochemistry. I just wonder if we can expand on this a little bit, and what can be done for the next IPCC assessment, for example?
Yeah, I'm not a modeler. I don't know how long it can be improved for these solar system models to address all these mesoscale features. As far as I know, all the models that they are addressing some issues like, for instance, oxygen deoxygenation or acidification in coastal waters of outgoing regions, they are coupled ROMS biochemical models. And these are giving yielding a very much realistic situation what is going to happen in the future. But as far as we know, these models, they cannot reproduce small scale features in the models. Maybe in the future, I don't know. But improve the models, of course.
Thank you. Yes.
Thank you. Sebastian Richer from JSOC, a small organization. I've got a question about EBUS. You presented the EBUS stuff without canary flow. So I am a little bit skeptical because why choosing 3 out of 4, not the fourth one as well? For canary flow of the you eliminated it from the analysis when you took the EBUS stuff.
I'm sorry, but I don't understand the question.
When you presented the flows on the impacts, there was a big table with all the impacts possible. You took the 3 ones, the one from Chile, the one from Western US, Western America, and you took the one from Western Africa, but not the northern one from Canary.
You mean the projections for
Yes.
Rakineski?
Yeah.
It covers the Canary current also, and it goes up to Iberia also.
Yeah, but this one was removed from the EBUS analysis. This is my question. Why? That was all.
Why the Iberian is removed from the EBUS in that? Well, that's a good question. No, it's a very good question because sometimes it's included, others not. And it's part of the recirculation. In fact, there is subgolide in that region, but it behaves completely different because you have the Strait of Gibraltar, which is splitting up the connection between the north and south of this region. But it's true that some modelers or even some people working on observational results, when they refer to the EBUS, they just include north of the North Africa, and others include the Iberia also. So this model projection paper of the people from California, they included all of them, but it behaved completely different to what is in the southern part. Thank you.
So thank you very much. My name is Luis Valdez. I'm working here in Spain in the Instituto Español de Oceanografía. So I'm trying to move the flag of the ocean in Spain. So I really appreciate the talks. All of them were very, very good and very illustrated, and also putting faces for the Inuits, for India and Seychelles. So thank you very much. I have one question for Elena. Elena, you show a lot of impacts in the biology, but I haven't seen anything about the hypoxia, the issue with the oxygen in the ocean. So I think this is one of the points that we have to highlight in terms of climate change and the future projections for the ocean and also for the biology. Do you have something to say about the hypoxia in the ocean?
So, hello. So the question, I'll just repeat it, it was about the impacts from deoxygenation of the ocean. So certainly some of the modelling approaches that I was showing, so the fisheries the fish models from FishMIP include parameters for oxygen levels in their projections. But when we look at the impacts we're seeing at the moment, overwhelmingly the attribution's been to temperature, but that's not to say that these other impacts aren't happening at the moment. It's just that we don't have the observing systems to monitor and to attribute them. So certainly, I think Lisa's going to disagree with me. So, oh, okay. So certainly deoxygenation of the water is a major concern. Some of the projections that I've seen at the moment are talking about are projecting a decline in habitat space for fish, so a 3D decline, so not only in latitude but from below, from above and below as well. So,
just would like to say that there's a 750-page report being released tomorrow at 9 o'clock in the Mocha Room by the IUCN called Ocean Deoxygenation, Everybody's Problem, and it is a very deep dive into this problem with pretty much everything we know in that report on this subject. 9 a.m. Mocha Room.
We shall all be there.
Thank you, moderator. I have a question to Elena. On your final slide, you wrote strengthening response options do you have any suggestions as to how to strengthen response options? And do you understand? Yeah. And another question is about the lady from Inuit organizations. My question is, how do you preserve your passions and patience in a very complex multi-level governance of polar regions? Thanks.
So with regards to strengthening response options, the slide was actually showing some of the actions that could be taken. So, for example, conserving coastal ecosystems not only has benefits in terms of carbon storage, but brings a range of co-benefits. So coastal protection, provision of food, wood, other products to human communities. And something else that I highlighted on the slide was engagement with local and indigenous knowledge. So maybe I will share this answer with my colleague next to me.
Yeah, thank you for that segue, because I do really strongly believe that decentralizing some of the research and getting into actual communities to allow for the co-production of knowledge and hearing from people, again, out there and on the ice, and we always hope there is ice, is a contribution to strengthening the response options. And that's why with my views and those of our organization go hand in hand with much of what was indicated in the report. So your question about engagement in a very complex intergovernmental organization, let me preface my response by indicating that since 1977, we've been active at the international level. In 1983, we gained non-governmental organization status 2 under the Economic and Social Council, and we are active in a wide range of UN activities, from the General Assembly to, of course, all the area of human rights, the entire human rights regime, as well as clearly the UNFCCC. And we were present in Brazil when the convention was adopted. And we've now are facing probably some of the most difficult time in the history of our organization because of the increasing and intense interest in the Arctic from non-Arctic states, from environmental organizations, from industry. And so we're not only is it the impacts of climate change, so the first wave, but also the compounding or cascading and spin-off effects of climate change, ranging from ocean acidification to microplastics to increased vessel traffic to, you name it, and we're hit with it. There's just constant fatigue at the number of researchers that do show up within our communities. The fact that I was recently in Nome, Alaska, in the Bering Straits, and right off the coast were 2 massive tourist vessels that delivered people into the communities. Where did they come from? But I think that, we have difficulty in attracting the financial resources that are responsive to the priorities that we set. And I'm actually very proud of our organization and the fact that we have the capacity and the ability to identify what our priorities are and go look for the funding to meet those priorities, rather than being donor-driven in a way that only perpetuates, in my view, green colonialism. And I think this is one of the important elements of things like the co-production of knowledge, is our direct involvement at every stage, and for us to identify what the priorities are. I'll admit, on a personal level, it's hard to come to a COP. I mean, it's really stressful. It's really traumatic. So when I was thinking, okay, ecosystems and human systems, well, this human system is going to break down. You know, it is, and there is also the emotional stress of it, because we are overwhelmed with just the adverse impacts. But we've remained optimistic. We estimate that there are 180,000 Inuit. We're like 0.00001% of the total human population, but our area and our homelands, our territory, I guess this is, I have to remain optimistic about it. But I think we're in a weight class in terms of, you know, our ability to have an impact that I'm actually very proud of for such a small population.
Thank you. Are there any other questions? Yes, Karen.
Thanks, Ove. And this actually may be a question for you and also the speaker who talked about what's going on in the Himalayas, because I think our worlds are often so divorced from one another, what's going on in the ocean and what's going on in the cryosphere, other than when we talk about the polar regions. But for me, listening to what was going on in the Himalayas was so telling in terms of the connection between those two things. And I'm wondering if there is any collaboration in the works or thought about how to bring some of those different pieces together, so we can show the connectivity between these places that we never think about, but that clearly in the IPCC report are so closely linked.
Absolutely. Who would like to take that one first?
So I think we did float an initiative. I'm not very sure in my previous organization, which was EC Mode, and that's a mountain organization. So we had floated an initiative with a very attractive acronym called H2O, which means Himalayas to Ocean. And that was really about the connectivity of the upstream and the downstream, because it's not just water, but it's also sediments. And then at the same time, we have been also, a lot has been written about debunking some of the myths. Some of the myths, such as the floods in the downstream are because the upstream smallholder farmers are irresponsible and don't take care of their landscape. So there has been a lot of research that has also gone in debunking some of those linkages, like myths. And then at the same time, initiatives are on to look at which are the parts of the puzzle that actually fit and which don't quite fit. But yeah, I think H2O sounded very exciting.
I think there are also cross chapters between sections on the cryosphere and the oceans. One particular is the polar oceans. Polar oceans, and chapter 5, they have a lot of links, and there are cross chapters about that also.
Sorry, Dali?
Yeah, just 2 quick comments. Because we're in the Arctic, we've been engaged in the Arctic Circle Assemblies, and there's been an interesting discussion about the Himalayas as the third pole. And I'm sure that others may have heard about this because of the importance of the ice and snow in the area. And so I was intrigued by your comments and the reference to the water towers and the mountains as water towers. But the second thing is that we're also involved as, our organization is involved as permanent participants in the Arctic Council. And my guess is that the working groups active within the Arctic Council, of which we're active in, for example, the working group on the protection of the Arctic marine environment, because of our dependence upon the marine environment, that this report will be taken up, and I'm sure already has been taken up by the various different scientists and others engaged in those working groups. And I should say that we still face a bit of a hurdle in the genuine co-production of knowledge in that context as well. But there's just a flurry of activity taking place just within the Arctic Council itself. So thank you.
Thank you very much. Well, unfortunately, we're going to have to close now, but I think there's been a really fascinating set of speakers' ideas that will probably flow on beyond this room, hopefully. So let's thank the speakers and contributors once again. I'm going to have to run to the next one. Well, thank you very much.